Welcome. Thank you for joining me again for our 1-4B lesson. So in this lesson, we're covering basically the same kind of topics, okay? Solving equations and solving problems by writing equations. But this time we're going to be dealing with a little bit of a different situation. Before we dive into that, I do want to take a moment to review a little bit of what we talked about in the previous lesson. So in the previous lesson, we talked about just solving equations, okay? Finding what value of x makes that true. We talked about that and implies getting x by itself. When you have something kind of messy, like what you're starting with here, remember you want to clean up both sides first by distributing and combining like terms. Well, here, this negative front of the parenthesis, that is really just a -1, right? That's what that negative stands for. So picture in that instance, if you just have a negative in front of a parenthesis like that, picture a -1 there that you're distributing, okay? So in that instance, this turns into 4 minus 3x. Well, -1 times -5 will turn into a +5. Then I can also distribute over there. All right, now that I've distributed, now let's see if I can combine me like terms. But the only ones I see are those two, 4 and 5. That is going to give me 9. All right, so have that now. Now both sides are cleaned up, but what I notice is I now have to get those x's together. So what I find easiest is I'm going to take the x that's negative and add that over, okay? Again, you could do it either way. If you wanted to subtract 2x from both sides, all the power to you. I think this is easier because this is going to keep things a little bit more positive as we work through. Okay, so 2x plus 3x is going to give me a 5x over there. Now, let's subtract the 6 off because it's completely disjointed from the x. So subtract 6. We're going to have 3 equals 5x. And now, of course, to get that 5 away, we're going to divide by 5. So x is going to be 3/5. And again, for the sake of the length of the video, I'm not going to do it myself, but remember, you can always go back. You can plug that in, right, to check to make sure that makes sense in the original equation. All right, so that was our previous notes, okay? So that's just solving an equation, right? Now, there is another kind of equation, and you probably haven't heard it called by this name before, but you do have some practice doing this. So a literal equation. A literal equation uses 2 different letters for variables. It has 2 variables in it. Solving a literal equation for a particular solution simply means to rearrange the equation so the variable is by itself. So in this case, when you have more than one variable and it says solve for one of them, basically all that means is get that particular one by itself, okay? So for example, right here, I want to solve this equation for s. So that means I want to get the s by itself. So P equals 1/3 S. All right, now, the 1/3. So usually when you say that, you're like, oh, okay, we'll divide by 1/3. You can. That seems to be a little bit messy, okay, dividing by fractions. We usually try to avoid that when possible. So I do want to explore a slightly easier option. Rather than dividing by 1/3, couldn't I multiply both sides by 3? Because if I multiply both sides by 3, 1/3 times 3, isn't that just 1? And so realistically, 1s is actually just s. And now s is by itself. Okay, so again, just a little trick of the trade. Instead of dividing by that, sometimes you can just multiply by something and it'll have the same effect. Okay? So again, that's just a very basic one, but again, just a good place to start to get used to the whole fraction thing. The next one we want to solve for k, okay? So here's my k, and this time we have kind of multiple things happening, right? We have it being multiplied by 6, subtracted by 2z. Well, it kind of follows the same idea as the equations we talked about in the previous lesson. Is I'm moving everything away from it, right? Trying to get the k by itself. So anything that is completely disjointed from it is going to be the first thing that goes, right? So what that means is I want to add this 2z over. So 6k equals, now here's a tricky thing. The 12 and the 2z, okay? Those are not like terms, right? 12 is literally just a number. The 2z, well, it has a z in it. It can't combine with a normal number. So remember, in this instance, you actually have to leave them separate, right? You can't combine those two things together. All right, well, we're close. Now I have that 6 multiplying my k. So again, I'm going to cover some of these words. So naturally, I have to divide by 6. So 12 plus 2z over 6. So this is a legitimate answer. Otherwise, I know some of you will want to say, well, we know 12 over 6 is 2. We know that would reduce to 1/3. So I know some people would want to do that, and that is a perfectly legitimate answer also. Okay, so either one of those would be absolutely beautiful. Okay, most people would probably just stick to the top because it's easier. You can just leave it like that. But just do be aware, some of you that are kind of thinking ahead, it would be the same as what I just put in green. Okay, you can divide both things on top by that single thing that's on the bottom. This next one. So I like this next one because it shows you sometimes there's multiple ways to go about doing this, okay? Sometimes there's more than one way to get that variable by itself. So here we're trying to get d by itself, okay? Now here notice the d is connected to the r squared because that entire side is being multiplied by 5. And what you're conditioned to do is like, oh, awesome, let's distribute that. So you end up with 5r squared plus 5d equals 10. So you distribute, you're like, okay, sweet. Now that 5r squared is disjointed from my d, they're not connected anymore. So I can subtract off that 5r squared. 5d equals, and again, just like we just finished talking about in the previous example, that 10 is just a normal number. 5r squared has a variable. They're not common, so they don't combine. You have to leave them separate. 10 minus 5r squared. And now, of course, final step, I need to get d by itself, so I'm going to divide by 5. Okay? So d equals, in this case, look, it actually turns out nicely. If I take 10 divided by 5, that just gives me 2 minus, here, negative 5 r squared divided by 5. Those cancel and just leave you with an r squared. So this one, it actually is nicer if you do take the time to actually divide out that 5 from both pieces individually. Okay? Now, I alluded to the fact that there is another way you could think of this one. So for this one, notice 5 actually goes into the 10 on the other side, right? So here I have two things being multiplied. The 5 is multiplying the r squared plus d. What if what if right away I had decided to divide that 5 off from the get-go? Well, that changes things, right? Now on this side, with that 5 gone, I just have that. 10 divided by 5 is 2. Now I'm still trying to get that d by itself, so I'm still going to subtract the r squared over. And again, notice those are not like terms, so I do not combine them together. But do look at my answers. My two answers match. I just solved this in two completely different ways, but I got to the same answer, okay? So just keep that in mind. Sometimes there may be more than one way you could go through these steps, this process, okay? Depending on your preference. And again, either one is great, as long as it gets you to the answer. So let's look at both of these now. Both of these, I want us to solve for y. And I do realize there's a typo. The first one doesn't have a y. So can you fix that for me, please? Change that t into a y for me, please. I apologize for that. So we're just going to change that to a y. And we're going to keep moving forward. So trying to get that y by itself, where there's two things happening to the y, right, as I'm looking at it, it's being multiplied by 4 and it's being divided by 5. So realistically, it doesn't matter which one you do first because remember, in PEMDAS, those are kind of the same speed. However, I have a preference, right? We usually don't like dealing with fractions. So the first thing I would likely want to do is I would actually want to get rid of that fraction. So I would multiply both things or both sides by 5 just to get rid of the fractional piece. It just sounds easier just to move that away, right? And then, of course, now I just have 4y left, still looking to get the y by itself. So we divide by 4. So 5uv over 4 is going to equal y. All right, the next one, similar story. So here, remember that 3 is connected to the y because of the ginormous fraction. So I can't move the 3 first. I have to deal with that t on the bottom first. So I'm going to multiply both sides. Excuse me, both sides by t. So y plus 3 equals, now here, t squared times t. You actually know that, don't you? T squared times t to the first. Well, this is a nice little review of rules of exponents. Remember, when you're multiplying two things like that, you can add their exponents together. So that's actually just t cubed. Now, my goal is still getting y by itself. Now I subtract that 3. Remembering that t is a variable, 3 is just a normal number. Those things in no way, shape, or form combine. So I leave it like that. All right. Let's keep moving along. So what about when the variable appears multiple times in the equation? So this presents a problem. So for example, for this one it says solve for x, but I see 2 x's. Well, that's awkward. Now you have learned about something called factoring, right? So when two things have a common term, I can actually pull that common term out. So this is one of those circumstances. The variable I want alone is represented multiple times. I'm going to factor it out front. I'm going to pull those x's together to take it away from the a and the b. Okay, I'm going to pull it out front. And the cool thing about that is, now notice I only have a single x. in my equation now. So this actually really simplifies things for me because now I have x multiplying that. Well, if I want the x alone, can't I just divide by that and cancel out that whole thing? So here is what you end up with. So again, this is a really cool example, again, for when your variable is being represented multiple times in the equation. Okay, and I do have another example of what that looks like. So here, I'm looking for u. Now, there is a dilemma in this next one. This time, oh yeah, I do see u multiple times. The dilemma is they're not on the same side of the equation. Okay, so when they're not on the same side of the equation, there is one little step first. The only way factoring works is if the two things are actually together. So I have to add that over, so now they're on the same side of the equation. Now notice UV and TU, they have different variables, right? So they are different things. They cannot combine together. So when you add it over, you do have to leave them separate, okay? Because again, they do involve different variables. But they both have the u. They share that u, and now it's on the same side of the equation. So I'm going to rip that u out front, away from the others. So now again, the perk of this is I have the u by itself, or a single u. Okay, so now divide off the v plus t, and you have u equals negative w over v plus t. And there you have it. All right, so let's work through our two quick word problems, and then we'll call it a day. So that equation relates temperature in kelvins and degrees in Celsius. What is C in terms of K? So C in terms of K. So what that means is we want what C equals using some expression of K on the other side. Okay, so again, that's just a fancy way of asking, well, solve for C, and then K is going to be on the other side with all this stuff. We can calculate C using that K. Well, if this is my formula, and my goal is to get the C by itself, well, that seems relatively simple, doesn't it? Can't it just subtract off the 273? Because that'll leave C alone. Remember, K is a variable. The 273 is a number, so you can't combine those together. You do have to leave them as two separate things. But look at that. I do have the C by itself now. If you notice the next example, F in terms of C. So what that means is we want this F equals, okay? F in terms of means you want this solved for F. F by itself, okay? So here we have 5/9 times F minus 32. So again, notice that 5/9, okay? That 5/9, that is multiplying that expression F minus 32. So if I can deal with this first, and get that to the other side. Well, notice I talked about multiplying. Now, what that means is on the bottom is the 9. So if you think you can multiply the 9 over, and then divide by the 5. Okay, so I undid the multiplication and division that were there. Now, some of you that remember your mathematical vocabulary, if you notice, I did just kind of use the reciprocal. 5/9, its reciprocal is 9/5. So if you think of it that way, that is another way that you could do this, okay? Right now, I think this is probably easier thinking of multiplying the 9 up, dividing by the 5. Well, now, last thing, let's add that 32 over, and f will finally be by itself. Again, 5/9c has a variable, 32 does not, so they do have to stay separate. But now we can calculate Fahrenheit using Celsius. So again, thank you for joining me for this. Now, this time I would like you to try a summary on your own, okay? So spend a couple minutes, write a quality summary for me, and then when you come back to class, make sure you are ready to do some practice work on all of this.